Hello guys, welcome to another episode of Dev's Kingdom. This is Jacob. In this tutorial, we're going to show you the latest image generation framework from Nvidia. It's called Sana. So it is an efficient HD image generation framework with linear diffusion transformer. It's super fast. And so if you go to the performance section, it claims to be better than Flux.Dev in all metrics. And it provides two types of models. One is Sana 0.6b. The other one is Sana 1.6b. And if you go to the other section, it will show all the other performance metrics comparing to PixArt and SDXL and Hongyuan DIT and DAO3, SD3, so on and so forth. And it seems to be outperform a lot of the models as well on different metrics. So in this tutorial, we're going to show how to set this up step by step on Kaggle. So interested? Let's continue. And there is a little bit issue if you set up on Kaggle because I think the code base has a bug. So I'll show that in a little bit how to fix it and how to set it up the easiest way instead of the way that you see the README here. So, and let's get started. So let's create a notebook on Kaggle.com and let's clone this repo and also set it to the Sana project. So basically, instead of using the environment setup, you have to basically just do a pip install for the Xformers dependency using 0027 post 2 from this CUDA 12.1 repo. Also do a pip install. So basically, it's a power to install. So do a install to all the dependencies, and then make sure you get the Hugging Face token. So they require Hugging Face to download Gemini. I think it's for LLMs, but I need a Gemini model. So basically, that's why I need a Hugging Face token. So you have to set that up as well, and then make sure you create a function to run bash command within Python, and also do a pip install for ngrok, and make sure you paste the ngrok token at this section. Get it from ngrok console, and make sure you map the public URL to localhost 15432, which is the local port for Sana. So let's go to the Sana code fixes. So if you actually run a Sana on Kaggle, then there's a problem with the GPU because Kaggle only provides 16 gigabytes of RAM. But if you use the default configuration from Sana, which is using this 1.6b params model and the image is 1024, then you will have a memory issue. So then that is because there's a issue in the code in the line 216 as the video is recorded. So basically it says device map equals to auto, and then if there's a lot of memory usage, it will offload everything to CPU. So if you set the two devices, it's gonna also set everything to GPU. So this will not work. Instead, for a Kaggle GPU, you have to comment that line out so you can do a auto GPU to CPU offload. So that's why you have to comment this line, and that's it. So after that, you should be able to run that on the Kaggle VRAM, and also make sure you create a demo port. So also set a demo port to 15432, which is where the public ngrok URL is gonna map to. So create this environment variable. Then also make sure that you use this configuration to 512 ms, not the demo one as this 1024. So this will not work on Kaggle because still the limitation of the VRAM. So use this 16 or 1.6b as the params, and also the image is 512. So this is probably the largest configuration you can have on Kaggle. And then also download the model from the efficient large model repo from Hugging Face. Make sure it's also use the this configuration Sana 16 and 1.6b 512px, and the checkpoint is the same. So make sure the image size is also set to 512. So that should be it. And go to this page, which is the public URL from ngrok, and this point to a local Kaggle environment. So this will be set up. So they also have cached all the default prompts to generate all these images from prompts as well, so it's super convenient. So once you click a prompt, you should be able to get the image right away. You can see how fast that is because it's cached, right? So, but if it's not cached, it's also super fast and it's very high quality. If you go to different images or different prompts, you can see everything is very high quality, right? And let's try one of the prompt and regenerate using a different configuration, so to see how fast that is. And remember, this is actually on Kaggle, so it's not the latest greatest hardware. It's a very consumer hardware. So, and let's check this image style and then just use photographic. Let's try that out. Let's see how it performs. So click this run. So use the same prompt, click run. You can see that it's very fast. So, and the reason being, it is using linear models. So see how fast that is. And it only takes about 5 seconds. So if you go to this matrix from Sana, so you can see that the speed up for Sana 1.6b is 23.3x, which is crazy. If you look at Flux, it only has 1. And for Sana 0.6b, it has 39.5x. So it's crazy quick. And let's go back to Sana's Gradle page. So let's try another one. So if you say a very detailed and realistic full body photo of a set of a tall, slim, and athletic Shiba Inu, right? So let's try to run that. Also choose a different style, anime, right? So let's try that. Let's run it. So again, it's very fast. This is way faster than Flux. So if you can see that, this is actually a anime style of Shiba Inu, which is very cool. And let's try another one. So maybe the professional portrait photo of a anthropomorphic cat. So let's try another one. So let's run this one again using the anime style. Super cool. So you can see that's very high quality as well. So it only takes 5 seconds. And this is it. So it's a very, very cool project. And I think it definitely helps if you want to run high quality image generation at your free time. So hopefully this is helpful. If you do like this video, please subscribe, like, or comment. If you have any questions, thanks for supporting the channel and see you in the next one.